In this video, you'll learn to solve distance, rate, and time problems. In our first example, we have a situation where two buses are traveling in opposite directions. So two buses leave a station at the same time, traveling in opposite directions. The rate of the faster bus exceeds the rate of the slower bus by 15 miles per hour. After 3 hours, they are 345 miles apart. What are the rates of the buses? Well, we have a lot of information going on here. The first thing that we need to do is kind of draw a picture to understand what's happening. And so we have two buses leaving a station. So I'll draw a picture here, and let's say here's our station. And they're traveling in opposite directions. Okay, so let's say here's one bus. Here's another bus. Again, you don't have to be an artist to draw a picture of these buses, obviously. One of the buses is traveling faster. So I'll say that this is the faster bus, and this over here is the slower bus. Okay? Now, after a certain amount of time, after 3 hours in fact, these buses are 345 miles apart. So the distance from one bus to the next now is this 345 miles. Now that we've kind of got an understanding of what's going on in this picture, let's go ahead now and fill in this chart. So the things that we're comparing the faster bus and the slower bus. First thing we want to find is the rate. Do we know the rates of these buses? And it says that the faster bus here exceeds the rate of the slower bus by 15 miles per hour. Well, we don't know how fast either of these buses are going, but we know that the faster one is going 15 miles an hour faster. So we would say right now, if I made them both x, that would say that these buses are traveling exactly the same speed. That's not the case. The faster one is going 15 miles an hour faster. So we would want to add 15 to this one. Okay, that takes care of the rates. Now let's go to the time. Well, both buses have been traveling for 3 hours. So we would put that in. Now we can use this rate times time equals distance to fill in these two distances the buses have traveled. If I take for the faster bus the rate times the time, it will give me a distance that this bus has traveled. Well, here's the rate, here's the time. So I would take 3 times x plus 15 to get that distance. Same thing with the slower bus, the rate times the time, and the way that we write x times 3 usually is just 3x. Alright, I've filled my chart in. Now I want to go to step 3, which is use the information about the distances to write an equation. Well, the distances are right here, 345 miles altogether. So if I take this distance of the faster bus, 3 times x plus 15, and add it to the distance of the slower bus, 3x, altogether, those distances have to add up to 345 miles. Now I have an equation. Now I can go ahead and solve this equation for x. So I would distribute the 3, which would give me 3x plus 45 equals 3x equals 345. Okay. Still simplifying on the left side, I would combine my like terms. So that would give me 6x plus 45 equals 345. Let's come over here to finish the equation. So I would want to now, let's write this down again. I would want to subtract 45 from each side. So then that would give me 6x equals 300. Divide by 6, and I see that x is equal to 50. Now I need to use that information to answer the questions they've asked. And they want to know, what are the rates of the buses? Well, I found x. I can take that and plug it back in up here to find the rates. So the rate then of our first bus, or the slower bus, is actually 50 miles per hour. And the rate of the faster bus is going to be 50 plus 15. And if I add 50 plus 15, I get 65 miles per hour. So now I have answered my question about these two buses traveling in the opposite directions. Now it's time to check your understanding of solving a distance, rate, and time problem. Pause your video player and answer this guided practice question. When you're done, hit play to see how you did. Okay, our question here. Battle Creek, Michigan and Louisville, Kentucky are 315 miles apart. A car leaves Battle Creek traveling toward Louisville at 50 miles per hour. At the same time, a bus leaves Louisville bound for Battle Creek at 55 miles an hour. How long will it take them to meet? Well, again, first thing we want to do is draw a picture. So here's Battle Creek, and here's Louisville. And this car traveling this way. So we have a car traveling this way. That box will be my car. And from Louisville, I have a bus traveling this way. We'll make the bus a little bigger. Okay? And it's somewhere in here they're going to meet. And we want to know how long is it going to take for them to meet. Well, we're going to have to fill this chart in to figure that out, but at least now we got an idea of what's going on. And so we're comparing this car and this bus in their travels. Let's see if we can find their rates. It looks like the car is traveling 50 miles per hour, so we'd put that in here for the car. 50 miles per hour. The bus is traveling 55 miles an hour. Let's check the time now. Do we know the time that these buses are traveling? No, that's actually the question. How long will it take them to meet? So that's going to be our variable. Now, these cars, the car and the bus started exactly at the same time, and they're going to meet at exactly the same time. So the time that both of these vehicles is traveling is the same. So we will call both of them x. Now that we know the rate and time, we can get the distance. So the one distance for the car is 50x, and the distance for the bus is 55x. Now we can go on to step 2. We're going to use this information to write equation about the distances here. Okay? So it looks like here's one of my distances, here's the other distance. Well, altogether, they're going to have traveled 315 miles because that's the distance from Battle Creek to Louisville, Kentucky. And so both of them have driven a piece of that mileage, but altogether that's what they've driven. So I would say 50x plus 55x altogether, that's going to be 315 miles. Now we just need to solve this equation. So I would add 50 to 55, which will give me 105x. Divide by 105. Let's come over here to finish. So we'll get x on one side, and if I do 105 into 315, that will give me 3. So let's see what we found. We found that x is 3, and if we go back up to our chart, that tells us that the time for each of these vehicles was 3 hours. Let's see, that was the question they actually wanted to answer. How long will it take for them to meet? So we would say it will take 3 hours for the car and this bus to meet.